In this video, we're going to talk a little bit about the standard template library. It's going to be just a fairly brief overview. We're not doing too much with it. We may circle back around later, and we may not. So the standard template library is an addition to C++. And I think that it came about in an effort to compete against languages such as Java and Python that have a bunch of built-in data structures. And C++ for a long time didn't. So this standard template library was something that the organization that runs the development of C++ put together as a way to help programmers out. Okay, so again, I think I've mentioned this before, that oftentimes new programmers are like, why do we have to create our own data structures when they're already built into the standard template library? And the answer there is that it's often the case that we want to be able to customize what our data structures are doing. We want to be able to make them more efficient, to do different things than the standards would do. And it's always better to customize things whenever you want. So again, you have a quick and dirty need for some data structures. The standard template library can be very good, but I think that in any sufficiently complicated program, you're going to find that you're going to need to create your own data structures, more flexibility. And the other thing is, it simply helps you to, as a programmer, helps you to understand what's really going on in the data structures by creating them yourself. It's different from just pulling them from the library. Okay, so the standard template library has a bunch of stuff that we're not going to get to, but overall it's organized in such a way. We have components of the STL. There are three major categories here. Okay, so the first category is going to be containers. Okay, we have a category for, I don't have the other two. That's interesting. There's one for algorithms. I really not put that in my notes. It's very sad. Anyway, there are three. There's containers, there's algorithms. Oh, there's iterators. Containers, I believe that's right. Iterators and algorithms. Okay, so it's containers that we're most interested in. The containers come in sequence containers. We have associative containers. And we have list containers. Okay, and of those, the sequence we're going to deal with, again, in this video, the sequence are going to be, we can do a vector, which we're going to cover. We can use a DQ, we'll look at a little bit, and also a list. Okay, the associative arrays are going to be things that are similar to a map in Python. No, dictionary in Python. Well, it's called map with letters. A map or a dictionary. And we're going to, the sequence is going to have a number as the indexing. Okay, 0, 1, 2, 3, whatever. Where an associative will be associating a name with a value, a name value pairs. Okay, and then the lists are just another way that we can organize things a little more complexly, which we're not going to get to. Okay? They're not the same as lists in Python, but they're along those similar ideas. Okay, we then have iterators, which we'll see today a little bit as well, that allow us to move through these data structures. Sometimes they're bidirectional, they can go forwards and backwards, and sometimes they just go in one direction. Okay, and then there's a whole section on algorithms. This is going to have things such as a copy to allow us to do a deep copy, so we don't have to create our own code for that. It also is going to do things, there are some sorting algorithms, other things that you can do. Okay, again, we're not going to look too much detail into those. Okay, so the first thing we're interested in, again, is the idea of vectors. We will go to some code in a minute. So the idea here is it is going to store and manage its data, or its objects, whatever you want to call it, in a dynamic array. Okay, the dynamic is important here. Remember, in a previous video, we talked about the active memory being divided up into the stack and the heap. Dynamic memory goes on to the heap. It also means that the user or the programmer is responsible for managing that. But remember, an addendum to the video on pointers, The newest version that I have installed on my Linux server of C++ apparently automatically creates the destructors to get rid of memory data in a class in the same way that it creates a default constructor. So we don't have to worry about that so much, but just know where it's going to be at, okay? And we get to all of these. The STL is implemented in a fashion that you can kind of pick and choose what you want, okay? So if I'd include with a vector, only if you type it correctly, okay, that's going to allow us to bring things in there, okay? And then as far as how we're going to use this, give some room here. Okay. And typing is superior to my handwriting, just so you know. So for example, all of these are typed. Okay, so we have to include whatever element type we want. Okay, and then give it a name like veclist. Note that this should be a small v in all of these. Okay, so that would create a vector called veclist. So if I were to say something like vector int veclist, that would create an example of that. Okay, other things that we can do with this. Okay, it has a built-in copy constructor, and then I can put an existing list, so another veclist as a parameter. Okay, then of veclist would then equal whatever other veclist equaled. Okay, we can also initialize this to a size. As a dynamic variable, we don't have to initialize it to a size. It's not like a normal array or a static array in C++, where we have to say how big it is, but we can give it a size automatically if we want. Okay, we can do things that feel a little Python-like. We can say in and then some element, so for example, we could say like 10, 0 would give us a vector of 10 elements of each element would be 0. Okay, so 10 zeros basically. Okay, we can also do a sequential one. We could do something like 100, 200. This would give us a vector that contained 100, 101, and so forth, all the way up to the end of that range. Okay, so we have some options there on creations. Some of the things we talked about as necessary for our any class that contains memory data taken care of for us already, which is nice. Okay, so we can then talk about some access operators. So let's say I've created this vector. We'll call it an int. Okay, so let's do something simpler here. Let's just do say 0, 10. Okay, so in essence, we're saying our vector looks like not very exciting, but you get the idea. Okay, so access, the basic way we could do this. Okay, we could say veclist we can just put in a position 3. Okay, this returns, in our case it's all the same, it's all 10, but this would return, we would have a 0, 1, 2, 3. We return this element of the vector. Okay, I do need another curly bracket there. Okay, we could also do a dot at, which is a function that also would return the same element. Okay, so other things we could do a vec list dot front, which returns the first element of the vector. Okay, we have a vec list dot back, which returns the last element of the vector. Okay, there are also things such as a clear, a dot clear, which again would be on the vec list, which gets rid of everything. We can do a dot erase, which takes a beginning and an ending element position, deletes those in the middle. Okay, we can do an insert, where we give it a position and the element that we want to insert. Okay. We have a pushback. Okay. And there is a space there in the pushback element. The home keys. Okay. And that's going to copy that element. Or sorry, not copy, insert. Insert element at the end of the vector. So we can use that to add new things along the way. Okay. There's a pop back. We'll see this push and pop in some of our later data elements or data structures. Okay. This will delete the last element. Okay. And doesn't return anything. Okay. And finally, we have a resize. And the resize is going to allow us, which would take some number here, okay, to change the size of the vector. And all these would have the name of the vector in front of it, okay? And then just to show the iterators, iterator again is just a way to allow us to move back and forth in the vector. Okay, so we would start by declaring the iterator. So it's a vector int. Okay, so each data structure that we have, whether it's a vector or a DQ or a list, have their own iterators, and they also have to be typed. Again, when we're iterating through something, we need to know how much size it's taking up in memory in order to move back and forth. Okay, so we have the vector int, that's our namespacing iterator. Each one has one, and then call it whatever we're going to call it. Okay. We then have to point it to something. Okay, so I could say my int vec iter is equal to some vec list that we've declared before dot begin. Okay, there's a begin, there's an end. Okay, that points it at the beginning of that. Okay, then we can dereference that. We could do like asterisk int vec iter, and that will return the element pointed to by the iterator. Okay. And then finally, we can do a plus plus. E there. Int vec iter. Okay, and that's going to advance it one space or one element. Okay. So just some basic ideas there. Before I switch to the code, just so I won't have to switch back, the other thing I'm going to do an example of, and I'll just do it by doing the code, is a DQ. I wish I was in a text editor, should have been. I just picked text edit, which I thought was a text editor. It is not. Okay, DQ, which is basically a double-ended queue. Okay, so queues, as I mentioned in the video on an overview of data types, we'll talk more about queues later, is basically a first in, first out data structure. Okay, with a double-ended queue, you can add things on either end. So it's kind of like a stack and a queue in one. Okay. Okay, so let's go to the code. I think that's the best thing for us to do, and look at some examples of how this may work for us. Okay. So I'm going to stop sharing this, switch over terminal window. Hopefully my whole desk doesn't fall apart in the meantime. Okay, so I've got here a vector example. We're going to work it, but I'll go ahead. And again, I've stressed this in these series of videos, the idea of ritual. Okay, so I always like to start off with the basic structure, things that I really need for my file. You could also save this for as a template file and copy it over. Perfectly okay. It's a smart thing to do. Okay. So in this case, I'm going to include vector. So I want to include that. The standard template library, again, it's standard. It's already there. We don't have to install it. separately. It's installed whenever you install your C++ compiler. Okay, we're still using our namespace standard. All that's the same. Okay, so we're going to start here by just creating a vector. Okay, so we're going to say vector int. I'm just going to call it int list. Okay, and this example in particular is from a book that's out of print, Data Structures Using C++ by D.S. Malik. I like the book a lot, and I've used it for a long time, but you can't get it as new anymore. Still out there though. Okay, so once we have this list, one of the easiest ways we can add to it is to use our pushback function, which has, sadly, a underscore, I'm not a fan of. Okay, so again, at this line, we have an empty vector. Okay, so it points to nothing. Okay, when we do a pushback, we've now added 13 as the first element of our list. Okay, at the end. Okay, and then I can do, just we have something to work with, int list dot push back 75. And then I can do a couple more. Again, being a basically lazy person, I'm going to do my kill and yank instead of cutting and pasting. Do a 28. And we can do a 35. Whatever you put is fine. Doesn't matter. Okay. And then we're going to go ahead and list out our elements here. At this point. And we're going to use the bracket method to access things here. In fact, we can go ahead and do this, keep it all in one line, save a little space in the terminal. Okay, so I can do a for. Notice I'm not using the iterators here. I'm just going to go the old-fashioned way. Int, initialize it to 0. We're going to do an I less than 4. We have 4 elements, so we do 0, 1, 2, 3. And then we're going to do an I plus plus. Okay. We're then going to see out each time through the int list at position I. Okay. Then going to put a space, and that's it. And then the right character. Okay. Then at the end, when we're done with our loop, we're going to do a see out just of a new line character. Okay. So to preview what this is going to look like, we put a 13 first. Okay. And then we add at the back a 75. And then we add a 28. And then we have a 35. So by pushing back, the 13 is going to remain the first element of our list here. Okay. So let's take a look at this, what it looks like. Assuming I haven't made any errors, which one never knows. Okay, there we go. It's in the same order we put it in, which is good. Okay. So the next thing we're going to do here, we're going to do the same thing, but this time we're going to use an iterator. Okay. So for this, okay, I'm going to come down here, and I'm going to say that a vector int colon colon iterator, I'll call it list it. Okay. So again, this is an iterator that points to nothing. We know it points to a vector of type int, but not to any particular thing. Okay. I can use this iterator in the following way. Okay, and I can put in a iterator. Okay. Again, this way. Keep it all in one line. Okay, and then I can do a for. I now have listed already initialized, but I don't have it assigned to anything. So I can assign it to my int list dot begin. That's my first position. Okay. So that's where I'm going to start. And then I'm going to go along as int list does not equal to not int list, list it does not equal int list dot end. Okay, then I'm going to do a plus list it. Okay, it's going to start at the beginning. It's going to go to the end, one at a time. I'm then going to see out. Again, these iterators are like pointers. They point to the memory address of the current position of the vector, which are not contiguous like a static array. It could be anywhere. Okay, but I can dereference that with the asterisk. Okay, and say asterisk listed. And the first time through will give us the first element, then it'll give us the second element, and so forth. Okay. Okay, and then put in my space. And then at the end, I'm going to see out the new line character. Okay. One thing that I missed is that to make sure that we are printing out something different and not just the same thing, okay, twice, we can go ahead and just do some manipulations here on our array. So I can say for int I is equal to 0, I is less than 4. Spacing doesn't matter, but it matters to me. Plus plus. Okay. Then each time through, I can say int list sub I times equals 2, or I could say that is equal to that times 2. Either one works. Okay. That should double all the elements there. Notice that when you just have one line in a data structure such as a for in a control structure like a for, you don't have to put parentheses, you don't have to put the brackets, but I like to put the brackets. I think it's clear, easier for me to read. Okay. So I'm going to go through now and run this now, and the second one should be different from the first. Okay. Again, I typed everything correctly. I did not. That's on. Oh, it's a listed. That's what I didn't do. You do have to put your variable names correctly. List it. That's the only time I did that. Now we're good. Run it. Okay, and we see that we have the first one is the original elements we put in. The second one is that all those are doubled. Okay, so that looks okay. Okay. And the last thing we want to do with this is we want to go in and look at the insert. Okay, so I can do the following. Okay, I could say listed is equal. See, listed only had a value inside of the for loop, so now it doesn't have a value again. So I can do an int list but dot begin. Okay, so at this point I'm pointing to the first element. Okay, or the 26 now in that first position. That was a 13. Okay, I can now do a plus plus listed. Okay, which will move the iterator to the second element, okay, or the one at index position 1, okay, which in our case is a 75. I can do a plus plus listed again, which will move it to the third element, not 75, originally 75, so 150. I'm now looking at the third element, okay, which has the index of 2, which was originally a 28, but is now a 56, okay. So I can now say int list, again, back to the vector itself, okay, insert. Okay, where do I want to insert it at? I want to insert it at the position of listed, okay. So this is going to go, we're currently pointing to the 28, okay. When we insert this 88, it's going to go before and push everything else to the right, okay. And again, we're going to put an 88 there, okay. So I need a semicolon. So once we've done that, again, I can just list my elements again. And we've done that before. We can use it with the iterator, it doesn't matter, but I can go ahead and copy this whole thing. my yank and kill. In the tab, we'll make sure everything's lined up correctly. Okay, I can now say list elements after insertion. Okay. And we should see, if I did it all correctly, that the 88 should be before the 56. Okay, so again, to show it on this screen, when we first set it equal to begin, we're here. Okay, when we do the plus plus, we get to point to this one. We do the plus plus again, we point to this one. Okay, when I insert the 88, inserts before this and moves the 56 and the 70 to the end. Okay, so our last one, we see that in fact the 88 went before the 56 and the 70s at the end. Okay, so that's how the vectors work. Okay. So the next thing I wanted to do, an example on the DQ. Okay. And again, in a course on data structures, it's important that you know what this stuff looks like, the standard template library, but it's not really the main focus, at least not of what I'll be covering. Okay. So let me find the other example I'm going to do. So again, I went ahead and did a Q test in there where I've put in the basics. Okay, but this time we're going to include some other stuff. So we can see some other things here. So we're going to include the DQ, double-ended Q. We don't have to use a double-ended. We can though. Okay. I'm also going to include the algorithm. See how that works. Things don't line up. The color's wrong. You got something wrong. Loosen Emacs. Not sure what VI does. One would assume something similar. This time we're going to include the iterator itself. Okay. Then we have our using namespace standard as before. Okay. And some comments would be useful, like it should have been the last one as well, but I'm not going to do that. So again, this looks like the vector, and that we're going to have to type it as an int. I'm going to call this int DQ. Okay. Okay, so one thing the book does, it's a little weird, but we'll go ahead and do it in this case. You probably won't see me do it again. We can do an O-stream iterator on an int, call it screen, and it's going to do a cout, and it's going to automatically put a space afterwards. Okay, this is just a convenience. I mean, we can do this certainly. Not a bad thing to do. I tend to not to, but everyone's different. Okay, so we have our int DQ. We're going to start with our pushback. Okay, so the pushback is common to all the containers. Okay, so we can always do a pushback on anything. Do a 13 again, like we did before. Then the int DQ dot pushback again. 75. Okay. And as before, I'm going to cut and paste. Or in Emacs terms, yank and kill. Oh, kill and yank, sorry. So we're going to have a 28, and we're going to have a 35. Okay. So we now have created our queue. Okay. I'll go ahead and print that out. So we're going to just be what's in DQ. So again, we're going to use our iterators here, but we're also going to use this iterator in a different way. Okay, that we're going to basically copy things to the screen, which is a cout. Okay, so it's a different way of doing things. Okay, so we're going to use copy, and copy is part of the algorithms. Okay, and what we're going to copy is the int DQ dot begin, where we're going to start, where we're going to end, the int DQ dot end. Okay, where are we going to copy it to? We're going to copy it to the screen. Okay, and screen is this output stream iterator that we defined above. Okay. And that's a real straightforward way to print things out. Okay, then we have to do, of course, at the end, do our cout, find your home keys, cout line. Okay. Let's just run this far, make sure we've got that set up correctly. There's no typos or logic errors or semantic errors or anything else. Okay, does not like that. Why doesn't it not like that? Let's see what I did wrong. I'm guessing I did something incorrectly. Okay, so we've got here our O stream. Am I including everything? I'm including the IO stream, the DQ, the algorithm, and the iterator. Okay. Then I've got the O stream underscore iterator. And we have a screen, we have a cout, we have a space. It should be okay. Don't know why that's not working. Very interesting. Let's check the error one more time. Was not declared. I'm including the iterator. It doesn't like. That's weird. It's. I wonder if this is a name. This again, the book's a little bit old. It's probably named something else in the most current version. Make sure I don't have something else going on here. No, that should be okay. Let me pause this to see if there's a new version. If there's not, then I will just go on without it. We don't need it. Okay, so I looked it up and it's one of those really strange errors. Apparently, I'm guessing screen must have become a saved word somewhere along the way. So as you can see, I did exactly the same thing I was doing before, but I changed the name from screen to out IT for the output iterator, outstream iterator, and it's fine. So don't know. We'll just call it out. It seems like I've been through this before. And again, that's a disadvantage of using an older version of a textbook. You sometimes have these issues. Okay, so now we can compile it and now we can run it. And you can see that it does give us the same as we did before. Okay, they're in the same order, which is good. Okay, sorry about that issue. It happens sometimes. If you're curious, I just did a Google on, that's probably not a bad thing to show. It's a good technique. I should have kept it rolling. Okay, what I basically did, not there, right here. I went to Google and I searched for the OStream iterator C++. I then clicked on c++.com, which is a good site. Okay, on that site I went down and all I was curious about was to see example. So I went down to here. Okay, and I saw this example. They're not using the namespace standard. Okay, so you have to delete that. But I saw this and how they were using it, just like we're using it here with the copy. Okay, I then was able to put that into my code here. Okay, no, that's what I wanted. That's not it. That's not it. That's it. Into here. Okay, and then I kept my old line, put the new line, and then that worked. So I was okay. Okay, just so we know how to find our own answers is sometimes useful. Okay. Okay, so now back to this. We've now printed out the elements in our DQ. So we have some options here also on the DQ. I can do an int DQ. Let's do a push front. Again, it's a double-ended queue. So I'm going to push a 0 to the front. Okay, that's going to put the 0 before the 13. Okay, we can also do an int DQ. Let's do another push back for 100, which will put that at the end. Okay, and then we can do this again with our simpler copy mechanism. Gonna kill it, gonna yank it, gonna come down here, gonna yank it again. Say elements after two insertions. Okay, make sure things are working properly. And then we see we've added the 0 is at the beginning, and the 100 is at the end. Okay, we can do that as much as we like in any order. Okay, so now that we've added them, let's go ahead and get rid of a couple of elements. Okay, we're going to use the pop front. There's also a pop back, but the pop front. So we're going to do an int DQ, name of our DQ, okay, dot pop front. Push adds to the data structure. Pop gets rid of it. Int DQ dot pop front again. Okay. So that's going to take care of the first two elements that we have. Okay. My kill ring is empty, so I've got to kill it again. Elements answer to pop fronts. And again, this deletes those elements. Okay, so I would have to use a front if I wanted to save those for some reason. Okay. After two pop fronts. Okay. So before we do that, let's take a look here. So this is what we have. So the pop front should get rid of the 8. It should get rid of the 13. So this third print should start with the 75 and go to 100. Okay, we did it correctly. So let's do that. And we start with 75, go to 100. Okay, so we're good. Okay, so we're about through with the things we want to do here, just to show that there is also a pop back. And I think it's probably straightforward enough that we can just go ahead and put them here rather than do two separate examples. Yeah, well, heck, why not? Let's do them separate. It doesn't matter. What I can do, again, nothing wrong with being lazy as long as it makes you more efficient. Okay, so I can now go through and do the pop back, okay, which removes the last element. It doesn't return anything. These are void functions. So let's see what we're likely to have after that. Make sure if we get the correct answer. And you see the advantage of the output stream. I don't tend to use them much, but there's certainly nothing wrong with them. They certainly make things nice and quick. We can use the copy it to the output screen directly. So it is worth doing. Okay. Oh, we didn't think about it. Okay. So anyway, we're here. We do two pop fronts, gets rid of the 0 and the 13. So that should get us to this. Okay, when we do the two pop backs, it should get rid of the 35 and the 100, and it does in fact give us the 75 and the 28. Okay, so let's see, last thing we want to do here, we're going to reset our pointer, our iterator. Okay, we're going to use it to insert something. Okay, so we're down to here now. Okay, so iterators are not special. We can recreate them again if we want. So, well, I'm not going to recreate it. I'm just going to set it. So we've got our DQ iterator, which is DQ it. Okay. Did we use that before? Seems like we did, but maybe we didn't. No, I guess we didn't use it. That was on the vector we used it. Okay, so we're creating one now. No, we're not. It must already be there. Let me check back in my code to see if it is there. Yes, we did create it at the very beginning. I thought so. If not, we would have to create it. Okay, so we're going to set our DQ int iterator. Okay, so this is recreating it. Okay, we're going to, there should be a Q up there, or bad things will happen. I guess it wouldn't if I make it consistent, but let's make it consistently correct. So I'm going to let my DQ iterator be equal to my DQ, my int DQ dot begin. Okay, so it's there. So it's now pointed at that first one, okay, which was, let's see, where were we at? The 75, okay. If I do a plus plus DQ it, okay, that's going to move it one more to the second position. which has an index of 1, and we're now pointing to the 28. Okay. So from here, if I go ahead and do an insert, so my int dq dot insert, I'm inserting it at that dq iterator position. Okay. So it's pointing at that second element, okay, which is currently a 28. Okay. I'm going to insert at that position a 444. Okay. So this should put it between the 75 and the 28. Okay. And then finally copy one more. One of these guys down to here. So after insertion. Okay. Should print it again for us. One more time. Doesn't like something I did. So happy at 43, which means probably something happened before that. Well, it looks okay. Oh no, it does not. That's what it is. It's a DQ int, not DQ it. Iterator. Yep, it should do it. See if that fixed it. Nope, still didn't like something. I'm still typing in something incorrectly. Falling apart at the end of the video. It happens. Okay. So I've got DQ int iterator DQ IT. And then DEQ IT. Don't know why it's not liking that. What error did it give me? Expected initializer on that line 43. So it's still that line it's having a problem with. We do it right here. I wonder if that's the problem. I wonder if it can't do it twice. Because oh no, that's just to close the queue. No, I didn't have that one. Okay. So I'm doing the iterator on line 43. Right here. It's okay up until here. No problems there. So I'm creating a DQ and oh, I'll get there eventually. That's a namespace for the iterator DQ. Now, hopefully now we're okay. I'm not going to make any promises. There we go. There we go. And we do, in fact. It was a long time coming, but we do, in fact. Again, when we put the first pointer, when we finally got to create, it pointed to the beginning of our int DQ. We then moved it one time to here, and then when we did the insertion, it did it before that. Okay. So there's a lot more to cover on the standard template library. Okay. In fact, there are entire textbooks written on the standard template library. But for our purposes right now, just to give an overview, I think it makes some sense. Okay. We're next going to move on to the linked list. We're going to create some linked lists and kind of go through those thought processes. Okay. But hopefully that'll be something useful for us as we go along.